Okay, just as a reminder, it's a quiz week, so we'll have a quiz on Friday. And so be on the lookout for that. And then also we have a homework 4 due tonight. So make sure you're not sleeping on the homeworks as well. Um, Today, yeah, homework 4 is due tonight. Today we're going to start talking about, is that big enough? Can you guys read that in the back? Is that big enough for you? Okay. Um, we're going to start talking about object relational mapping, which is a topic near and dear to my heart. It's basically, we're going to talk about tools. So, I've said this before, but we're working in Java, and Java is object oriented, and the currency of Java are objects living in memory. You might not think of it that way, but if you take a step back and think about it for a second, what's going on when you run a Java program? The JVM has fired up and has grabbed some chunk of memory and is, you're newing up objects and things like that and wiring them up in what could be described as an object graph. And the JVM is doing all sorts of nice things like garbage collecting and all this for you. But you're a Java programmer. You work with Java classes. You create new fields, you create new methods, and all that stuff. That's living in memory. When we're talking about databases, we're talking about relations that are living in tables in some sort of data structure that we'll talk about later on in the class. And they're just two different things. Like the database is on disk, Java, the JVM is in memory, and all the rest of it. There's this in general was recognized. Object-oriented programming it wasn't the start. So early SQL programming would be done just in raw SQL because computing was so primitive, and so people would just run a query and then like print it out on one of those old dot matrix printers that were so rad or whatever. So it was that was how you typically interacted with databases. But as soon as object-oriented programming took over the world, and there were still databases and there's still uses of databases, it introduced this problem of mapping database rows to objects. Like, how do we do that? And so any system that does that is called an object relational mapper because it's taking objects and mapping them to relations, or it's taking relations and mapping them to objects. Typically, they go both directions there. So you've got some database, it's got a customer table and a bank account, and then you've got a customer object, which is attached to a bank account object. So this is sort of the UML view of the world, and this is the relational view of the world. And the ORM sits in between those two and tries to keep things straight between the two of them. In the class, you're working on files in source main Java CSCI 440/model, and you're effectively building your own bespoke ORM layer because you're working with the raw JDBC, right? Like you're working with result sets and blah, blah, blah. And you're mapping in the constructor, you can go and look at the constructor in the model. That's where we're actually taking a relation in the form of a very bad API called result set and mapping it into an object by moving values out of the current cursor in the result set and into the object fields. Okay, so that's where, again, I think I said before, that's where the rubber meets the road. So I think that's good because you get to see the actual SQL. You get to write raw JDBC, which would be considered pretty low level for most professional working environments. But when you're in a professional working environment, you're almost certainly not going to be working with JDBC. There are specialized situations where it comes up, and I think it's useful to have this knowledge, and so that's why we do it. You'll almost certainly be working with an ORM of some sort, okay? So here's an example of some raw JDBC and then the equivalent ORM code. So this is raw JDBC, which should be pretty familiar. I've omitted how to get a connection and how to get a statement, but you guys have seen all that in the code in your code base. But you say statement.execute query. I should pass in some SQL here, but you execute some query. And you get a result set, and then you can do something like result set get string and pass in the column name. So this is low-level JDBC. If you were using an ORM, and this should be people, not persons, but whatever, it's all good. Then what you would do is you would have a person object, and you might say something like person.find.byId. And what that's going to do is that's going to actually issue a query behind the scenes for you. The ORM system is going to wire in all the necessary SQL and issue the same query that we have up here, but it's going to do it, and it's going to map everything into fields on the object. So exactly what you guys are doing, but the ORM takes care of most of the magic for you instead of you having to do it. Okay. So then you can just call person.getName. And I think if you look at these two things, like, I don't know, to me, it's pretty obvious which world I would prefer to live in. I would prefer to live in this world. But I also think it's dangerous if this world is the only world you know about, if you don't know about the low-level stuff underneath it, which is why in this class, again, I make you work with the lower-level APIs, okay? So that's what an ORM looks like. It certainly looks nicer. It's typically less code, especially for simple things, and most database accesses are pretty simple. Like, you're on a web page and you want to find, the thing that's associated with that web page, and maybe all the other things that are in some one-to-n relationship associated with that thing. And that's really not super complicated SQL, and JDBC is kind of a nightmare to deal with if that's all you want to get done. You also often have better code completion. One thing that can be really nice with ORMs is that they'll provide something called fluent APIs, which make it easier to express what you want in a tight manner. We're going to look at some fluent APIs in the next lecture when we talk about we get down into the muck with a couple of ORM tools. They often update automatically when the schema changes. So you can, if you make a change to the schema and you rewire some field names or something like that, then you have all the nice refactoring tools that you would normally have in Java. You don't have just random strings sitting around in SQL that can break because suddenly some column has gone away or something like that. So a lot of good things about object relational mapping tools. And one thing that I will say, I need to actually get I'll post a link to the essay on it. But a lot of people are very negative on ORM tools. So if you go online and type in ORM hate or something like that, you're going to find a lot of people that hate ORMs. And I understand that, but I also, and they do have problems that are associated with them, which we'll talk about in a second. But I do think in general, they're the right thing. They're typically the right way for the way I do development anyways. I would prefer to have a decent ORM. The bad news, if you're in Java, is that there isn't a decent ORM, at least not until next year when I release mine, and then there will be a good ORM. No, I'm just kidding, but you can look at it and judge it. So there are downsides to ORMs. The first one and the most obvious one is that you're obviously less connected to the database. So you've abstracted away from the database. That means that you don't necessarily know all of the details of what are going on in the database. You might not even know the database schema. You just have objects that you can load, and it can be really tempting when you have ORMs to load up objects and crawl all over them like you would an object graph, because it looks just like you're invoking methods. It doesn't look like you're invoking queries. But queries are expensive. And so a thing that people complain about with ORMs is that it's easy to introduce performance issues because you'll invoke a getter and suddenly that will invoke like 100 queries, and you don't see that. You just see a getter, just like get, tracks or something like that. Like, why is there 1,000 queries happening now? Well, that get tracks or whatever has some complicated logic underneath it that causes a bunch of queries. Another problem you can run into with object relational tools is it's tempting to implement algorithms against the data in memory. So you might do filters by iterating over an entire list and then doing the filters in Java logic rather than taking advantage of a where clause in the database. It's a very common thing to do. And, take that idea and make it, even bigger and more abstract. You're walking around looking at different objects instead of doing the right thing, which is to create a complicated query with some joins and so forth. And that, so that disconnect, the fact that it doesn't tell you like this is a bad idea, often makes people dislike it. The SQL that's generated by object relational mapping tools can be pretty awful to look at, and it can be hard to understand as well. So a lot of downsides, and again, I'll try to find, what I'll try and do is I'll try and find two articles, one that's like, I hate ORMs and here's why, and then one that's an article on why ORMs are good, and you can read both of them and see sort of both sides of the story. In general, I think this is one instance of a general class of problems in computing, which is abstraction, which, the cause of and the solution to all of life's problems when you're a computer scientist, right? Whenever we abstract, it's like, it's catnip for the computer scientist's soul, because like, okay, now I don't need to worry about that. And if you took 366 with me, we have assembly abstracting away from the hardware. We have compilers abstracting away from the assembly. And that makes programming tolerable. Like, programming would not be tolerable if we were still back in the days when we were punching, holes in paper to indicate machine instructions to execute. So those abstractions are very useful, but they also come at a cost. And, when you're talking about ORMs, that cost is you don't understand the SQL that's being generated. It's not obvious to you how things work under the covers. Again, that's why I structure this class the way that I do. So you do see that stuff under the covers. And that happens in the world of assemblers and compilers as well. So you'll hear people complain about the assembly that compilers generate, because the compiler doesn't know all the details that a good assembly programmer knows about the machine. And so whenever you're introducing abstractions, there's danger lurking. And so that's, I guess, one philosophical takeaway from this class is my general warning that computer programmers, particularly the smarter ones, are prone to reaching for abstraction too quickly. And that can lead to difficult to understand systems. So in the Java world, there are a million ORMs. There's about to be 1,000,001 ORMs, unfortunately. But probably the most popular, the most dominant is what's called Hibernate. And this was first released back in 2001. I remember very vividly this being released because at the time I was a brand new programmer I was working for Bank of America. Don't do as I say, not as I do. It was after the dot-com crash, so just like, any boat will do in this storm. I was I was a pretty good programmer, and I was part of the group that was making decisions about the database, how we were going to work with the database. And we knew about ORM tools at the time, but they were all proprietary. Tools. And and they were expensive. I mean, this was back when you pay like $20,000, $30,000 a year for a piece of software. And good days. Those were good times. One of the companies came in and gave a presentation on how their system worked, and I looked at it and I liked it and all the rest of it, but the price was really steep, and I told my boss, like, this is great, but this is really, really expensive. And I remember the sales guy got a hold of my phone number and called me while I was at Bank of America and like read me the riot act for like being this little, this junior suggesting that their software was too expensive. He was talking about how he was going to get me fired and like all this crazy stuff. At the time, it was pretty scary. But I remember like that week, I also found out about Hibernate, and I just sent him an email with a link to it. That was my response, was like, hey, because Hibernate was open source and free and all the rest of it. So it's created by Cirrus Technologies, which has now been through a series of acquisitions acquired by Red Hat, one of the evil, gigantic tech companies that we appear to have produced in the last 20 years. But it's still open source. It's incredibly widely used. There are alternatives, many alternatives that I like better. Juke, Apache Cayenne is good. ORM Lite is pretty good too. And we're going to talk about Pica ORM on Wednesday, which is the ORM that I'm creating. And I'll give you sort of the background of where that came from in that lecture. So the Hibernate architectural model is basically it's typical Java, super complicated. There's a data access layer, and then there's two APIs. There's two different APIs that you can use. Java actually has a standard, what's called the Java Persistence API, which I think I mentioned previously. We don't use the Java Persistence API at all in this class. You guys just work with JDBC. But JPI is a standard that all of the ORMs can implement if they want. And most of them do, but it sucks. And so they almost all implement their own API as well. And so that's how Hibernate is. You can use the JPI API if you want to use the standard, but nobody likes the standard. So then they all have their own native APIs. And then underneath those APIs lives the Hibernate implementation. And then underneath Hibernate lives JDBC. So just like you guys are building model classes, and underneath the model classes lives JDBC, think of Hibernate as a layer that would sit in between your models and that JDBC. If we were going to add Hibernate to our project, we would add it and then slot it in underneath the models, but above the JDBC access. Okay, and that's all JDBC is in Java, is just how you talk to relational databases. Okay, so here's a table, just a simple contacts table with an ID, first, last name, middle name, notes, starred, and website associated with a contact. So simple, not super useful with no phone number or email, but a contact nonetheless in a database. And if you wanted to map an object, a Hibernate object to this in Hibernate, what you would do is you would use what are called Java annotations. And you've probably seen these in the test classes, that @test thing. If you've ever wondered what that is, what that syntax is, that's what's known as Java annotations. And there's a link in the lecture notes if you want to learn more about Java annotations, or take 468 with me, where I talk about them in a little bit more detail. But they're basically a mechanism for associating information about associating metadata with features in Java classes. And so Java annotations are used when appropriate to map fields to particular database columns. In this Java class, which is mapping that, what we've got is it's annotated with the @entity annotation, which is a Hibernate annotation. Actually, it might be a JPI. I forget which API it comes from, but it's what you're going to use when you're using Hibernate. And you're going to say name equals contact, and this should be lowercase c. Sorry about that. This is the table that you're going to use that this class is going to get mapped to. So this class is going to get mapped to a table by the @entity attribute. Okay, and then you annotate the ID column with the @ID annotation, indicating, or I should say, the ID field with the @ID annotation and the @generated value annotations. And what that tells Hibernate is, okay, this is the primary key. The @ID would be better called primary key, but they like ID, so welcome to Java programming. Enjoy your stay. So ID is my primary key, and then it's a generated value, which means what? What kind of column is that going to be? What's the terminology we use for that? It's a synthetic key, exactly. It's a synthetic key that's going to be generated by the database when we insert, and so we have to mark it as an @generated value so that Hibernate knows that doesn't need to be there, and when I do an insert, I need to look for that value, the value that was inserted into the database, so I can put it into the ID column on that object that just got inserted. Okay, very standard, like run-of-the-mill ORM type logic. Okay, shoot, I dropped an annotation here. Oh, no, I didn't. So one thing to note about this class is that there's, instead of having the name fields, there's a name object that's in the contact object. And note that it is annotated with @embeddable. Okay, the @embeddable annotation. And what that's telling Hibernate is effectively this object is embedded in the table associated with this object. That's what that's saying. So let's go back and look at our schema really quickly. So our schema has first, last, and middle in the contact table, right? But here, whoops, but here, we have, instead of those fields, first, last, and middle being strings on this contact class, they're strings on this name object. So you don't say contact.first, you say contact.name.first, contact.name.middle, contact.name.last. So it's an embedded, it's what's called an embedded object. And you know, don't worry too much about the details. The big thing to take away from this is that there's a divergence between what the database looks like and what the object-oriented world looks like, right? Like if you go and look at this in the database, you're just going to see one table, contacts, and first, middle, and last are going to be columns in that table. But the way this has been modeled by the programmer that's been doing this work is, oh, I like name as its own object. So I'm going to annotate it. I'm going to create a class with those fields that all get mapped properly. I'm going to annotate it with @embeddable so that it feels more object-oriented to me. What do you guys think? Do you like that approach, or would you keep the stuff directly on contact? How many people would keep the stuff just on contact instead of using @embeddable? How many people would use @embeddable? Okay, interesting. I would probably keep stuff on contact because I don't like moving away from the database model personally. That's like my own opinion on it. Again, the big takeaway here is that there's a divergence, or it's possible, and this shows a problem. We're going to talk about like sort of the really deep problems next week with ORM tools. But this shows the problems with ORM is that there can be divergences between what your object model looks like and what the underlying database looks like. And the further those get apart, the harder it can be to reason about the system. So Hibernate also supports associations, which are how two entities basically are related to one another. So we've got our three types: one-to-one, one-to-many, and many-to-many. So here we have a person and a phone entity, which are mapped to person and phone tables. What you'll see is that there's a relationship between the two. Scroll down a little. So there's a relationship between the two, namely a person or a phone, excuse me, has a many-to-one relationship with person. Okay, and so for the many-to-one situation, let me boot this. Hold on a second. Now we're good. Okay. So we've got our person class. What happened? Hold on. Oops. Sorry, guys. Bear with me. Okay. So we've got our person class and our phone class. How would this be modeled in a database? Have like a people table and then a phone table, and then which side would the foreign key go on? What's that? Phone side, because one person can have many phones. So you would have a person ID on the phone side. Okay. So we've got a person, we've got a phone, and a phone has a many-to-one. There are many phones for one person relationship, and that is expressed with yet another annotation. So yes, this is a many-to-one. There's a join column. The join column is person ID, which is on the phone table. Maybe there's a foreign key that's associated with it as well. So you can have foreign key declarations in your DDL. You guys saw that from the DDL lectures, okay? So this is telling Hibernate, okay, there's a field on this phone object, and if they ask for that field, you need to issue a query to get it from the database, okay? That's what this is telling Hibernate, all right? You can also go the other way, which is more useful in my opinion. Or I don't know if it's more useful, but it's the way I think about things, which is a one-to-many. So a person obviously has many phones. So how would you declare that in Hibernate? Well, you would say something like list phones equals new array list, and then you would say one to many mapped by person. So it's mapped by the person relation on the other side of this relationship, which is going to be through the phone. And it's going to cascade, we're going to cascade deletes and all that stuff into that table. And orphan removal basically tells Hibernate if there is a phone that doesn't have a pointer back to the person table, then delete that. That's bad data. That's what that means, okay? So the details of this aren't super important. You guys aren't in this class going to be using Hibernate in any serious manner. It's just a vibe. It's like this is the vibe when you're dealing with ORMs. You're declaring fields and then you're mapping them to some sort of relationship in the database, okay? That's the general idea. Also, you can do something similar with many-to-many relationships. One thing to point out is that many-to-many relationships on one side of the relationship look like a one-to-many relationship. So consider tracks and playlists. A track has many playlists, right? A playlist has many tracks. That's a many-to-many relationship, but if you're just looking at tracks, it just looks like a list of playlists. If you're just looking at playlists, it just looks like a list of tracks. So even many-to-many relationships, you don't need any weird data structure, like there's no n-by-n data structure or anything like that to represent it. The relationship, when you're looking at an individual entity, still looks like a one-to-n relationship. And so it ends up being code that's very similar to this, okay? But that covers all of, or almost all of the relationships that you would normally deal with. When we're specifying, or excuse me, when we're specifying this mapping here, again, we're deferring to the remote table to define how it's mapping into this list. It's the remote table that sets that relationship up. Hibernate recognizes that and correlates them. So here's some example Hibernate code working with the person and phone class. We knew up a person, we knew up a couple phones with some funky phone numbers. We add the phones to the person, and then we do something called persist, and then we do something called flush, and then we remove something, and we remove a phone from that list of phones that we saw earlier, okay? And so this looks like pretty normal object-oriented programming, right? There's not anything weird like insert or like blah, blah, blah. There's a little bit of stuff down here that we got to figure out. But this, by and large, looks like everyday object-oriented programming. And that, I think, is the good thing about ORMs, is it makes what is kind of a foreign world, the relational world, pretty object-oriented-ish. It's just when trouble crops up that things get kind of bad, okay? Now, you'll notice session.persist and session.flush. What are those things? That's Hibernate's session API. And the main way that you interact with Hibernate is via a session object, okay? So this is the API that Hibernate provides that allows you to basically say, okay, it's time to save these objects. It's time to save these objects. Sessions in Hibernates have a pretty simple life cycle associated with them. You open it, you perform some operations, and then you close it. What does that sound like? JDBC connections. So it's similar conceptually to JDBC connections, but it's not as stateful as JDBC connections, so it's not as painful on the database as opening a JDBC connection. It also does some really nice bookkeeping for you. So here, I omitted that. We'll take a look at that code later, though, when you see that, okay? So what we've done here, and this is one thing that can get Java programmers into trouble, is so we've created a person and a phone, and we've added the phones to the person. Are we, at that point, what is the state of these objects? What's the state of these objects? They're wired up in memory, but they're not persisted to the database, okay? So they're sitting in memory with these relationships wired up. And if you ask this person for the phones, you're going to get these phones out of it. But it hasn't been saved to the database. So if the power goes out, that relationship goes away. Okay. And this is really where the ORM comes into play. When we say, okay, it's time to persist this person, and that's going to look at the person and say, okay, I need to generate the insert SQL for this person. And then, okay, it's got 2 phones. I need to take the ID from that person and wire it into the phone objects on the person ID field, and then save those all over the database. It's going to do that in one transaction, kind of in one chunk. In fact, that doesn't happen during the persist. Persist figures that all out, and then flush is what actually sends it to the database. Why is there a distinction between persist and flush? Because Hibernate is over-engineered is the answer to that question. But it is, okay? So what does this look like in SQL terms? What's the SQL equivalent of this?
Insert person with a new phone number and or the 2 new phone numbers.
Yeah, there'd be an insert person first, and then you'd have to get the ID that was generated by that insert somehow. And that's database specific. And then there would be 2 insert statements for the phones, right? That's what the SQL would look like. And like, how different is that than what we have to do here in Java? It's very different, okay? So they're just very different flavors of programming, okay? Let's go, yeah. Hibernate does support transactions as well, and transactions here mean pessimistic transactions. So if you want to acquire database locks while you're doing operations on objects, then you can do so by getting the transaction associated with the session and starting it, and then either committing it or rolling it back. So again, this is the way to think about the session object is sort of like the connection object in JDBC. It's effectively your connection, but it's not as heavyweight, and it does additional stuff on top of what the connection does, in addition to working with objects rather than with just strings like the connection object does, okay? You can do querying with the Hibernate session. So session.get, this is the way querying by ID works in Hibernate. You say session.get, you pass in the class. So this is the class of things I want to get from. And then you pass in a primary key. So this is one long. 1L stands for a long. If you've never seen that before in Java, that's a 64-bit integer rather than a 32-bit integer. So what this is saying is issue the SQL necessary to select a single person from the person table, and I want the person with the ID 1. This gets the person with the ID 1 out of it. You can see that it returns a person. You can also create queries. And there's 2 different flavors of query languages in Hibernate. Another reason I'm not a huge fan of Hibernate. There's something called the Hibernate query language, which is HQL, and that's an object-flavored version of SQL. So they were unhappy with the developer having to know the details of the database schema. They wanted to hide those details from the developer, and so they came up with HQL to do so. And so if you look at the HQL here, you don't say from some table, you say from some class. So capital P person, from person, where, and then you can do normal kind of SQL-y looking stuff, but it's just using all of the object-oriented ideas. So it's a different query language. It's a little bit strange. I do not expect you to know the details of HQL. What I want you to take away from this is that Hibernate is bad. Don't take that away from this. Hibernate has a lot of functionality, and HQL is one of those pieces of functionality, and you may go into an environment, if it's a Java environment, and run into an awful lot of HQL. It's a possibility. It is an object-oriented sort of take on the SQL query language, okay? One other thing to note about HQL, and one thing I do like about it, one thing in general I like about ORMs better than JDBC, is that you have named parameters. So what do we do in SQL when we have JDBC connections? We've got a prepared statement. What do we do? What do we put in there? A question mark. And how do we set the value? Yeah, an index number, which starts at 1 for some reason, right? Like lots of bad decisions in that API. And have you found yourself counting question marks in a query yet? If you haven't yet, you will soon. Like you're going to have a bunch of question marks and you're like, okay, what's the 4th question mark? Oh, it's the name of the tracker or whatever. Okay. So then you have to like line that all up. It's terrible. It's a bad way to go through life. And HQL and Hibernate, to its credit, instead uses a named parameter binding mechanism. So rather than a question mark, you just say colon and then some name, and then you can bind those parameters by name. And so this, because it's using ID, using the string ID and the value 1 in a 64-bit integer, that's going to get bound to this equals expression. And that's much nicer in general. It's much easier to read. It's much easier to write. You can reuse the same variable in multiple positions. So for example, when you guys do your advanced query and there's a min and a max, I think, or which one, I forget what, there's an example where you end up passing the same value for 2 different parts of the same query. And it's just like, this is dumb. And it is dumb. But the JDBC API is just bad in that regard. So named parameters are a good thing that came out of Hibernate, and thank you, Hibernate, for that, as much as I don't like some of the other stuff about it. You can use raw SQL, so this is just raw SQL. This is not HQL, and the way Hibernate determines that is that you start with a select rather than just with a raw from. So this is just raw SQL. So here you have to use the actual database table and column names. You can't use the object-oriented language that HQL layers on top of that stuff. And that is what I would prefer. So create native query just uses a native SQL query. And that's what I would prefer if I was using Hibernate. When you have relationships like many-to-one or one-to-many, when you have these relationships, one thing that comes up is the notion of whether or not they're eager or not. Typically, these relationships are lazy. So what that means is if you've got a phone, you don't issue the SQL to load a person for that phone until someone asks for it. Until someone calls get person, you're not going to issue the SQL to load that person up. And that makes some sense, right? Like if you've got a phone, then like maybe you never ask for the person. So why bother stressing the database to get the person information as well? Okay. So if you write this code and don't do anything else with the annotations, you're going to get 2 queries. This one's obviously a query. This one maybe not so obviously a query, but if you know the details, if you know what's going on underneath the covers in Hibernate, this is going to be a query as well. Okay. So from a performance standpoint, in some cases, if you know you're always going to ask for the person associated with a phone, it would be better to issue a single query, right? It would be more efficient rather than issuing 2 separate queries to the database to do 1 query, join the phone to the person table, and then just have all that information in 1 row. You can populate the person object and the phone object from 1 query. Let the database do the heavy lifting, okay? And if you want to do that in Hibernate, what you do is you add a property called fetch equals and then give it a fetch type, and you pass it the eager type. This is an enum in Java. So what this does is it flags this particular property for Hibernate to load the person object whenever the phone object is loaded, okay? So that's what that's going to do. It'll be aggressively fetched when you ask for a phone. So what's an issue with this change? Well, the problem with this change is that, you know, someone can come in and they're working on their part of the system, and it's like, I always need a person when there's a phone, so I'm going to make it eager. right? And then you're working on another part of the system that doesn't need the person. Suddenly your queries are slower because that join does take more time. It's faster than 2 queries, but it's slower than just one query against the phone table. And so you may find yourself fighting with another person over whether or not a particular part of a relationship should be fetched aggressively or eagerly or lazily. So lazy is typically the default and typically the right thing. But the way Hibernate works, and this is something that I'll show you how it works in the ORM that I'm building on Wednesday. But Hibernate puts that choice on the field itself, rather than like when you're building up the query or something like that, which I think would be much better. So is what it is. Hibernate has a very elaborate caching layer. It has three levels of caching. So one thing that happens when you're writing database code with object relational tools is you can accidentally end up calling the same query over and over again. So for example, if I'm on a person and I call get phones, that issues a query to get all the phones for that person. Cool. If I call get phones again, should it reissue that query? Yes or no? I see a lot of people shaking their head. It's a trick question. The answer is it depends. Sometimes you want it to be, sometimes you don't want it to be. Often you don't want it to issue another query. Often you don't want it to issue another query. And so what does that imply? Well, you got to cache the results of that query somewhere, okay? And so Hibernate provides 3 different layers of caching. The quote that I want you to come to mind, well, I want to come into your mind whenever you see the word caching in any context, is that there's only 2 hard problems in computer science: naming things and cache invalidation. So cache invalidation gets at what I was saying, where it depends. Like if you say get phones and it caches that result, and then someone else in some other part of the system adds a phone for that user, and you call get phones again, do you want to see that update or not? That's the cache invalidation problem. That's the cache invalidation problem. And so it's not clear necessarily that you always want to cache that result after the first time that you make it. It's a case-by-case basis. And invalidating caches is very difficult. So what does that bring to mind? I hope it brings, or I want eventually for it to bring to mind to you, wait a second, they've got 3 levels of caching. Holy crap, that's like crazy. Invalidating 1 cache is hard. Invalidating 3 caches is very, very hard. And so Hibernate has a very elaborate architecture to it, and that can make it really difficult to reason about cache invalidation issues because of that. Hibernate, and so this is my sort of segue into why I hate Hibernate. I don't hate it, you know. We're developers, so we say we hate everything. But Hibernate is very complicated, and it's the standard in Java, and like many standards in Java, it's just very over-engineered. And I think for day-to-day, like just basic applications, it can be a huge pain to set up. We're going to look at that on Wednesday. And it can also be just really difficult to reason about because it's got all this, like, do you really care about 3 levels of caching, like for your class application? No, but if you use Hibernate, you got to deal with it. So you pay the price for that, even though it's not necessarily very useful to you. And yes, you can turn them off and blah, 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 but now you got to figure out how to configure it and all that sort of stuff. So that's the crux of why I'm not a huge fan of Hibernate, even though it is the standard, and you guys will probably work with it if you end up working on Java. Hibernate, to its credit, does understand optimistic concurrency. So we talked about optimistic concurrency. It's actually pretty nice. If you've got a version column, you just annotate it with the @version attribute, and then that will be treated like that entity will be treated like an optimistically concurrent entity. And so when you do updates, you're going to have a version number in those updates. So you're going to select and then have a where clause where not only the primary key, but also the version key is going to be in it. And then it's going to throw an exception if an optimistic concurrency failure has occurred. Okay, that's really nice. And I've said some mean things about Hibernate, so let me say that that's a really nice thing about Hibernate, and I'm a big fan of it. And that's it. That's like our overview of just like what object relational mapping is. It's a way to map in-memory objects to database rows and rows to database objects. You guys are doing this as a bespoke, basically ORM system within the model classes. You're doing it by hand with JDBC, but it's the same problems. And then Hibernate is like the standard, so that's why I use it for all the little features. I don't expect you guys to be Hibernate experts. I just want you to see the features that you can expect to see out in the real world when you go and work with Hibernate-based systems. So in our next lecture, we're going to look at an actual Hibernate system configured to work against Chinook DB. And then I'm also going to show you Pika ORM, which is the tool that me and a couple other students are working on for this class and also for the web class in the spring, which is a simplified version, simplified ORM. All right. Have a good one, and I will see you guys on Wednesday.